Hi, Tyler Shada. We have heard that you are considering building a tiny house in San Diego. As part of building a tiny house, choosing the size of your waterbed is very important. A water collection system involves a water pillow under the house that needs to be large enough that your house will not run out of water. Based on how much water you use and how much you gather, that will affect what size waterbed you need. This can then also be based off of the precipitation data of your city that you're basing your house in.
We went to the National Oceanic and Atmospheric Administration for San Diego's website to find precipitation data for San Diego. We looked at the daily precipitation data from 2015 to 2019. The temperature maximum, minimum, and average were recorded for each entry. The set shows what the total rainfall in inches was on a certain date.
We did some calculations with this data set. It was found that the average precipitation was 0.024 and the standard deviation was 0.139. The average temperature average was 65.59 with a standard deviation of 6. The average temperature minimum was 59.953 with a standard deviation of 7.019. The average temperature maximum was 72.689 with a standard deviation of 6.976.
We determined that our water usage data was normally distributed with a mean of 10.303 and a standard deviation of 1.357. Using this information, we generated random, normally distributed data to simulate actual water usage. We then took the data from the National Oceanic and Atmospheric Administration for San Diego and calculated the rainfall collected each day. Using both this information and the water usage simulation data, you could run the simulation a large number of times with new randomly distributed water usage data each time and collect the lowest capacity data from each simulation.
Using these lowest capacity values, calculate a 99% confidence interval of the average lowest capacity. If the minimum tank level, which we selected as the maximum water usage estimate for 95% confidence, is within the confidence interval of the average lowest capacity, then a larger tank size is needed. We were able to determine that the size of the tank we need is 12,100 gallons. The large size of this tank can be explained by the abundance of droughts in California. This would mean that we would need to be able to hold more water in order to have enough in reserve for extended drought periods.